Hi, welcome to Varenya's Photon Online Educational Academy. This is Guntuka Srinivas. This is a free online educational channel meant for 8th class students to the 12th class students, standard levels. And if you like the video, please share it and subscribe the channel. In the previous session, we have seen some problems related to the distance and displacement concept. Let us see some more problems related to the same concept. Let me take up the first problem. In the given figure, calculate displacement. Calculate displacement. He is asking the displacement. And figure is provided. A circle is given. This is the complete circle given to us. Clear? This is the center of the circle. Okay. Let us say O as given. Clear? Now, this is the radius. This is the radius. R is the radius. And there is another. This is also radius. R. Clear? Now, this is the point given as A. This is the point given as A. And this is the point given as B. The angle between them is given as 120 degrees. 120 degrees angle between them. So in this case, he is asking what is the displacement. He is interested in displacement. Initial point is A, final point is B. OA is radius R, OB is also radius R, and angle between OA and OB is 120 degrees. Clear? That was the problem. Let us solve this problem. This is the given circle. This is the complete given circle. Okay. Now this is the center. Oh. This is OA R. This is OB. Again R. This is the initial point A. This is the final point B. Angle between them is clearly given of 120 degrees. Clear? Okay. Now, what is the meaning of displacement? He is asking the displacement. Displacement is nothing but, in this case, shortest distance between the initial and final points. Initial point is A, final point is B. The shortest distance between the initial and the final points. Clear? Now, if I join A and B, if I join A and B, this is the shortest straight line distance. The length of the straight line joining initial point A and final point B is known as displacement, or otherwise shortest distance between initial position A and final position B. This is displacement. Clear? Now observe. I want to generalize this concept. Yeah, I want to generalize this concept. Let us say I want to take this 120 degrees as theta. 120 degrees as theta. That means in this case, OA bar is one vector, OB bar is another vector, and AB bar initial to final point is displacement vector. That means OA bar is one position vector, position vector, position vector. OB bar is another position vector, position vector. The first one, OA bar is initial position vector. It is initial position vector. Whereas OB bar is final position vector. Final position. Then in such a case, displacement AB bar, initial point to final point, shortest distance AB bar is, we have seen in the previous sessions, classes, final position vector OB bar minus initial position vector OA bar. Yeah, final position vector OB bar minus initial position vector OA. That means the difference between the vectors OB bar vector, difference of OA bar vector. Difference of the vectors is nothing but this is displacement. Displacement. Yes, AB bar. Okay. Now, I want to relate this concept to the general vector. Observe, this is a vector A bar, let us say. This is another vector B bar. This is RSC, let us say. And the angle between these vectors is theta. Here. Now, line joining this point to this point, this is displacement. Displacement vector, let us say R. R is the resultant displacement vector. OB bar, OA bar. OB bar, here I am giving the literals A, and this is B. OB bar minus OA bar. That means AB bar vector, which is R bar. Let us say R bar. R, which is equal to OB bar final position vector minus OA bar initial position vector. Okay, that means if I simplify further, R bar resultant, the displacement vector R bar is OB bar. OB bar is what? B bar minus A bar. Final position vector minus initial position vector. This is nothing but R bar. R bar is nothing but this AB bar. Nothing but displacement. Nothing but displacement. Okay. Now, to find out the difference between two vectors, we are taking the help of the parallelogram of vectors. In the previous session, we have seen triangle of addition of vectors. We have seen parallelogram of addition of vectors in finding out the result. Let us take the same parallelogram now to find out the difference of the vector. There we have seen addition of vectors, resultant of the vectors. Here we want the difference of the vectors. Now observe. Here I need OB bar minus OA bar, B bar minus A bar. So can I write like this? B bar plus minus of A bar. Just B bar plus minus of A bar. Nothing but B bar minus A bar. Clear? Now, what is minus A bar? Minus A bar is nothing but same magnitude A, but reverse direction. So here it is, direction is changing. I'm extending the reverse direction. Minus A bar. This is minus A bar. Minus A bar. And how the clarity? Minus A bar. This I am putting it as A dash. I am putting it as A dash. Clear? Now, observe carefully. If this is the angle, theta is the angle, then this angle is how much? Complete, this is 180. Here to here is 180. If this is theta, then this angle becomes 180 minus theta. This angle is 180 minus theta. That means the angle between B bar minus A bar is 180 minus theta. Clear? Now, what is this saying? It is only addition. Addition of B bar to the minus A bar. The plus symbol says addition of B bar to the minus A bar. That means in the addition of vectors, I can make use of parallelogram of forces. Now, what is the parallelogram? Here I am constructing a parallelogram. Let me take up a parallelogram. The resultant here is, this is the resultant. Because addition is nothing but resultant. This is the resultant. This resultant is here. In between B bar minus A bar, the resultant is this. Resultant is nothing but summation. B bar minus A bar. Sum. Resultant is sum. Clear? And this is parallel to this. So I can indicate this as R bar only. R bar only. Clear? No, I am completing this resultant. So this is complete parallelogram. This is complete parallelogram. And this is here like this. Okay. And in the previous session, we have seen that if one vector is A bar, another vector is B bar, and this is R. If angle between them is theta, and the resultant is R. Now, this resultant is R bar. Then if I construct a parallelogram like this, if this is the parallelogram, if I construct a parallelogram like this, what is the resultant given? Resultant R bar is given as square root of first vector magnitude square plus second vector magnitude square plus 2AB. Magnitudes of first vector A, second vector B, and cos of the angle between them. And the cos of the angle between them. Theta. In the same manner, if I apply here also, what is the first vector in place of A? First vector is minus A. Second vector is B. Second vector is B. And the angle between them is, here it is theta, here angle between them is 180 minus theta. If I apply here, in this case, R bar is equal to this case. Be careful, this case, down, parallelogram case, R bar is equal. A is a magnitude. Observe here, this is minus. Minus stands for direction, but magnitude is what? A only. So A square. This is B. Magnitude is B only, B square. Plus, again A. Magnitude is say 2A, and B. Magnitude is the cos of the angle between them. Angle between them is not theta, 180 minus theta. So 180 minus theta. Square. Clear? Cos of 180 minus theta from trigonometric principles minus cos. Minus cos. So now just R bar becomes a square plus b square minus 2ab cos theta square. That means difference of two vectors, the difference of two vectors is given as R bar, which is by means of this one. And be careful, where theta is angle between the initial and final position vectors. Be careful about this theta. 180 minus theta is the angle between b bar minus a bar. That is 180 minus. But theta, I am underlining the word. Theta is the angle between initial position vector and final position vector. This angle only we have to take. Clear? So this is the formula to find out the difference of the vectors. Here I clearly write difference of vectors. Difference of vectors. Difference of two position vectors. Difference of two position. This is the formula. Is it clear? This is the formula. Okay. That means in the above case, we have used same parallelogram. Now, whatever we use it to do for the addition of two vectors, the same parallelogram law is also used to find out the difference between the two vectors. But how the difference has been written as p bar plus minus of p bar. Clear? The direction has changed. After changing the direction, addition we have taken, and that addition we have found by means of the parallelogram law addition rule. Clear? So this is the formula. Here afterwards, wherever you want to find out the difference of two vectors, you can directly use this formula. But be careful, theta is the angle between the initial position vector and the final position vector. General formula. Now, let me apply this formula to our problem. What was our problem? Our problem was given like this. This was the circle, or is it? Now, this was R. This was R. This was also R. And this was initial point A, final point B. Angle between them was 120. That means theta was 120 given. So in this case, it needs displacement. It needs displacement AB bar. AB bar is the displacement. In this case, it requires displacement AB bar. Displacement AB bar. Clear? And be careful. This is 120 degrees. Now, okay, can I use the same formula here? OA bar is one position vector, OB bar is final position vector. Angle between them is theta. Difference of two vectors, I need this AB. So AB bar I require, displacement vector I require. Difference between final position vector OB bar minus initial position vector OA. Difference between the two vectors. What is the formula for difference between two vectors? Just now we have seen A square plus B square, magnitude of first vector, magnitude of second vector square minus 2 into AB, magnitude of first vector, magnitude of second vector, cos of the angle between the two position vectors. A stands for magnitude of first vector. What is the first vector? OA. What is the magnitude? R. Radius. So R square. What is the magnitude of second vector OB? R square. Minus 2 into R into R OB. Cos of the angle between. What is the cos angle? 120 degrees. 120 degrees. 1. Clear? This is R square plus R square, 2R square minus 2R square. Cos 120. Here I am writing cos 120 can be written as cos 90 plus 30. Clear? Cos 90 plus theta. Cos 90 plus theta is minus sin theta. Okay, minus n. Sin 90 plus theta is cos theta. Cos 90 plus theta is minus sin theta. Have the clarity, that is minus sin theta. Okay, so minus sin theta is how much? Minus half. So this is minus half square root. So here on simplification, cos of 90 plus theta minus sin theta. So 2R square minus into minus plus this 2 goes R square. This is so root 3 into R. On simplification, the displacement AB is root 3 into R. Yes, root 3 into. Now, instead of finding out by using this formula every time, I generalize the formula. Observe, if this is a circle, this is a circle. If this is a circle, yeah, this is R, is it? And if this is radius R, if this is radius R, clear? If this is a position vector A, OA is initial position vector, OB is final position vector. If we need the displacement AB, shortest distance between A and B, initial point and final point. And if theta is the angle between two position vector, theta is the angle between two. What is the formula we use it? AB is final position vector. AB bar is final position vector OB bar minus initial position vector OA bar. That means difference of two vectors, two position vectors. What is the formula we are using? A square plus B square minus 2AB cos theta. Theta is the angle between the two vectors. Now, in this case, what is magnitude of first vector in place of A? R. Magnitude of second vector B? R, again OB. So R square plus R square minus 2 R into R into cos of the angle between them. Okay, that means 2R square minus 2R square cos theta. 2R square is common out. 1 minus cos theta under root 1 minus cos theta under root. Here. Okay. And observe carefully. This is nothing but AB bar. AB bar is shortest distance between initial point and the final point. Displacement. This is displacement. Displacement. Well, generalizing. I am generalizing. AB bar is this. Now, further I want to simplify this. From trigonometry, we have one formula. 1 minus cos theta is written as 2 sine square theta by 2. This is the formula from trigonometry. Trigonometry. Now I replace in the previous equation AB bar displacement. So square root of 2r square into 1 minus cos theta was formed. In place of 1 minus cos theta, I write this. So 2r square into 2 sine square theta by 2. We are providing directly here this formula here square root. So 2 into 2, 4. If I take out 4 out, 2 square root of 2 into 2, 4. 2 square root 2. R into R square root is 2r. Sine square theta by 2. Sine theta by 2. Sine theta. This is nothing but displacement AB bar. This is the general formula to be used anywhere to calculate the displacement. That means, here I quote, if this is a circle, if origin is this, if one position vector is R having magnitude, another position vector is also R having magnitude. If this is the initial point A, if this is the final point B, if the theta is the angle between them, then in such a case, the displacement, shortest distance between initial and final point, straight line, AB bar is simply given as displacement. AB bar is simply given as 2r sine theta by 2. Sine theta by 2. This is displacement. AB bar displacement formula. Why had this formula? You can have this usage anywhere. Yeah, simple. Here I am giving some simple application also. Simple application. Let us say this is a circle given. This is a circle given. Origin. Let us say this is radius r. This is, let us say, r. And this is initial point A. This is final point B. Angle between them is 90 degrees. This is theta. And let us say displacement is asking. What is displacement? Shortest distance between A to B, initial point, final. In this case, I apply the formula. What is the formula? AB bar displacement is 2r sine theta by 2. Example. This is an example. I have taken. Yeah. So, simple case, circle is given. R, theta is 90 degrees, quarter circle. In the quarter circle, AB bar displacement is 2r. What is the angle in between them? OA is one position vector, initial position vector. OB bar is another position vector, final position vector. Angle between them, theta is how much? 90 degrees. So 90 by 2 means 45. So 2 are sine 45 degrees. 2 are sin 45. How much? 1 by root 2. So on simplification, becomes root 2 into r. AB bar displacement is root 2 into. This is the application of this formula. Application of this formula. Okay, you can apply anywhere. Find out the shortest distance. Okay, hope you have understood the problem carefully. In this case, we have found the difference of vectors. In the earlier cases, we have found the addition of vectors either by means of triangular addition or by means of parallelogram. But in this today's case, we have found the difference of vectors by means of the parallelogram law. How? Parallelogram law is only useful for addition, but by making use of same parallelogram law, we found the difference of vectors. The difference of vectors b bar minus a bar can be written as b bar plus minus of a bar. Minus indicates reverse direction. That is b bar minus a bar, both are added by using the parallelogram law. Clear? The resultant is 4. That was square root of a square plus b square minus 2ab cos theta. Be careful where theta is the angle between the two position vectors. Initial position vector and final position vector. Yeah. I end up this session. Thank you for your patient listening. If you like the channel, please share it and subscribe. Thank you very much. Practice well.